Hello, everybody. Welcome again to another episode of Yarns with Andy. Today, I've got vigilante builder
Oh, God.
Murphy O'Neill from Adaptable Structures. Welcome, mate.
Hey, thank you. I appreciate you being here, and I appreciate the crew.
Yep. It's awesome having you here. And I'm quite excited for this episode today, to be honest.
It's going to be good.
Yeah. I bet it's going to be good. And we're gonna
Stay tuned for the door prize.
we're gonna talk about all the vigilante things that you've been up to in the building sector.
Yeah. Well, kind of have to.
You reckon?
Yeah, you kind of have to.
Let's talk about adaptable structures.
Okay.
Yeah. What do you guys do?
Well, I mean, the idea in the onset is to address construction in general and the lack of evolution in construction.
Right.
I mean, 2011 with the Christchurch earthquake and all the repairs and things that had to be done to traditionally constructed homes sort of makes you realize there's a wasted opportunity as far as evolving construction. And so part of that evolution is not just method, but materials.
Right.
And looking at the sustainability of materials and the addressing the waste issue that occurs in construction as well along the path. You know? So, I mean, it's been a long road, going from that idea to concept, to drawings, to prototype, to proof of production is been a long cycle, but primarily that's because you got to find the right people to work with.
Yes.
And
you need the right structure. You need the right environment.
Yeah, you got to find the materials, the methods, and all of that. And each one of those, processes you look is like a 4 to 6 month process. So it's not just a, come up with an idea, build it, and you're done. It's constantly evolving. So that's.
But get back to the root of it. What do you do at Adaptable Structures? What do you build?
Okay. The logic being is that we're building homes, and homes are essentially boxes, right? Yep. You look at even the room that we're in right now is a box.
Yep.
Now, if you break that down, it's wall.
Yep.
But the problem is in this method that we're currently using in order to alter any part of this structure, you create waste. So with us, what we're doing is we went back to the very beginning, okay? And we looked at other industries. And one of the ones that I'll reference quite a bit is the aircraft industry and a little bit of a background in that. And by doing that, you look at that pretty much everything on an aircraft can be retrofitted, it can be modernized, it can be repaired, replaced, or whatever else units.
It's interchangeable.
Everything is interchangeable on that. And that's between series of aircrafts, all those parts interchange.
Yeah.
And
because space is gold on an aircraft, isn't it?
Yes. Well, it's airtime. You got to have it in the air. It doesn't make money on the ground, right? Yeah. So when you look at those things and look at the complexities of an aircraft and how an aircraft is manufactured, then you go, well, how come that applicability can't be taken back into housing construction? So where we're currently at in the method or in the way things are done right now is we're trying to industrialize a method of construction, which is the old method of construction. But by doing such, we inherit all the issues that were previously known in that method. We're not changing anything. We're just putting it in a factory, assembling it in a factory. So what we did over our development period of time was look at designing out all those inherent problems, right? And the waste, the structural integrity, the longevity of materials, and the adaptability of a structure so that you don't have to essentially generate waste while you're in this process. Because like a house as well as a living being, in that a house changes depending on the occupancies or the use of those houses.
Yeah.
And traditionally we're in this role of if you have a baby, you got to move a house.
Yep.
If you
got to buy another house, sell the house you're in.
You got to keep.
Well,
moving.
we did that. Yeah.
Yeah. And like I had a discussion, as I mentioned, I was in an interview this morning, and we've all had that first home that we bought, and we've gone out there and we planted that avocado tree or whatever it is, or buried a pet in that yard. How many people actually still live in the house that they planted that tree, or ever reap the reward of planting that tree? You know, it's 5 years before the first avocado comes off of a tree, or whatever it happens to be. And when you drive by that house 10 or 20 years later, because you've had to move on, and you see those people enjoying that thing that you planted, which was your intent to do when you did it. Oh, okay.
No, don't worry.
Okay.
We're good.
Yeah.
Keep rolling.
So essentially what we looked at was that. Why can't you have connection with the land?
Yeah.
Right. And you get this property, you own this property, you're the caretaker of that land. And then instead of having a house that is a static thing, is creating a dynamic thing.
So there are other products out there in the market that go containerized houses, tiny houses. Yeah. How are you different?
Well,
what differentiates you?
Again, you take that information, that's the learned experience from those things. And like we look at the container homes, steel is very carbon intensive for one. Plus it also has the potential to corrode. Yeah. It has to be maintained and painted and this, that, and the other. The other thing is that when you look at putting a bed across a container, it pretty much covers the container, you know? So there was a dimensional issue that's in there. I'm not saying it's a bad thing. It's actually a good thing that there is that type of thing that's being done. But I think they're essentially missing the point of sustainability for one. The care and maintenance of a structure, the ability to adapt the structure.
Okay, and I want to get into that a little bit, right? So I'd say I get a tiny home, I get a containerized home, we call it whatever. I plonk it on my tiny piece of land that I've got. That's not an adaptable structure. It's a set structure, which is immovable. So you've got some models in front of you.
Yes.
Just the first key question I want to ask you is, what material are these houses being built with?
Okay. The material that we're using, is readily available globally, but we're using McKechnie aluminum in New Plymouth. Okay. And McKechnie,
so using aluminium.
Aluminium. Okay.
So aluminium traditionally is not a structural element, is it?
Well, that's what they tell you. Okay.
Okay, cool. Tell me more. I want to know more.
Well, I mean,
why did you choose aluminium? The product of choice, aluminium, to build a structural element is just not the norm in the industry.
Okay,
you know what I mean?
Let's do that's a multi-part question. First,
I know.
Let's deal with the structural integrity of aluminium. They build rockets and they build airplanes out of aluminium.
100% they do.
Okay.
Yep.
So I mean, we can
it's
dispel
structurally
that
sound.
myth.
Okay, cool. There we go. That's what I want. That's what I wanted to hear. Let's go. Okay.
Yeah.
So aluminium.
That question's answered.
Yeah.
Okay. Cool. Okay, we'll start with why use aluminium, okay, as far as a material. For instance, aluminium we can make a shape out of aluminium, and we can extrude that shape, and we know we have repeatability in that shape, okay? It's produced over and over again. I mean, hopefully we're a good enough designer that we allow variability in that shape to use for multiple applications.
Okay.
But we can design the shape. Instead of having to mill a piece of timber, we can extrude that's already pre-done. Yeah. Okay.
When you say extrude that, you mean die cast it?
No, it's not die casted. It's squirted out like a Play-Doh set. So molten aluminium comes through
and then
extruded
you
out in a die.
Yeah.
And you get relatively a uniform part. Okay. There's a plus or minus that occurs there. But again, we're not trying to invent an entire industry. We're trying to use what's already out there. Yep. All right. And with aluminium, because of its use in aircraft and other industries, marine industries, or whatever, all the machines are already out there to do the drilling and tapping, and they all exist. Okay. Yep. So we don't have to create any of that. Yep. What we have to create is essentially a structural box, but that box has to work with the materials that are already existing in the construction world. Yeah. So there's no reason for us to redevelop a window. So why not make a part that mates to a window? Okay. Right. And by doing that, in the majority of windows that are manufactured in New Zealand, Australia, pretty much globally, the majority of materials that are out there in the building and construction world are all designed to work with 4x2s, okay?
Okay.
But like, think about a 4x2. In order to put a window in a 4x2, we have to surround it with waterproof material.
Yeah.
Why not make a wet side, dry side?
Yeah.
Okay. You can't really do that with timber because it's got to be dry.
Mm-hmm.
All right.
It has to be dry.
Yeah, it has to be dry. All right. With us, we can make a wet side, dry side because we don't have the corrosional or moisture absorption issues.
So, did I hear you right that you've got no timber in your structure at all?
Not in the structural element of it. No.
Okay.
No.
But it's adaptable with timber for roofing, for
cladding.
Cladding.
Okay.
Yep.
I mean,
so if I wanted timber cladding, I could get timber cladding put on.
Of course. I mean, it can be completely bespoke. All right. But that's not the intent. Again,
agreed. Yeah.
Okay.
You want to be sustainable. I get that.
We want to be sustainable, but you also want to maintain affordability.
Yes.
Right.
Okay. That's interesting.
We can go into the economics of aluminium as well in a minute, But what we do is we have an extruded material that comes out a straight line, and that material is machined. All the offcuts, the sawdust, so to speak, the swarf that comes off of that recycles right back into the system.
Oh, wow.
So there is absolutely no wastage in that.
Yeah.
And luckily, working with McKechnie Aluminium, they recycle aluminium. So there's up to 90% recycled material that's going into the content. So all the beer cans, all the leftover warbirds from World War II that were here, there's part of that aluminium in this aluminium that we're using. So
wow, that's
it actually
cool.
has a history. 60 to 80% of all aluminium ever produced from bauxite is still in its use cycle. So it's a
reusable material.
It is a very reusable. 5% of the energy to remelt. Okay. And that's what McKechnie does is they remelt the aluminium. That last portion of raw aluminium or virgin aluminium that goes into it is an alloying material. So, you still have to have some new material that's being fed into it.
So I just want to loop a little bit back to what you were saying earlier, right? So say I've recently just gotten married, hypothetically.
Yes.
I've been married for 10 years now, but never mind.
I'm not, I don't want to know. Plausible deniability.
All right. Okay. So I've got married. Now I buy 2 modules from you.
Yes.
Are you calling them modules? What are you calling them?
Module. Yeah, that's the easiest thing to do.
Yep.
Yeah.
So I have a kitchen in one. I have I can arrange it. What are the different variations I can arrange those 2 modules?
There's relatively no limitations. The limitations that we have now are our structural approvals that we're getting on the units, okay?
Yep.
Like these units can be partitioned, and as we found, early on, because you have to visualize the spaces and it becomes somewhat difficult in a digital world to say that's a bathroom and that works, you know? So we've developed a method of partitioning that goes along the joist, so you can partition the building to go to suit, half being a kitchen and half being a bathroom, which is, everybody tells me, is quite a large bathroom to have a 7.5 square meter bathroom. But now that can be partitioned to a toilet, laundry, and then a kitchen and breakfast area, or all the way over to this is a kitchen and a dining area.
Or if I'm throwing a massive party, I just move those partitions out.
You can take them out. You can change the internal of the structure anytime you like.
Without compromising the structural integrity of that box.
That's right. The structural integrity is all built into this. So we don't need the walls essentially as a bracing element. We created a structural element that deals with that in a very basic minimum. So all our testing goes on this basic structural element.
Yeah.
Right. So as you were mentioning, you can buy the 2 modules, you can put them together however you like, right?
Yeah.
The end point of this is like a number 6 Lego block, is that you can stack modules. Okay. So we're going through the structural
How many levels high?
It depends on what the structural people come back with. That was not traditionally a consideration when we started the line in 2011. Is one of these things that it's grown into this capability. So for us, it was the single story. You've got the family that's growing. You just get married.
Yep.
You start out from uni, 100K. You come down and you drop in a structure into your property.
Did you say 100K?
Each module is 50,000. Of course, it depends on what you're fitting them out with.
Cost price or sell price?
Sell price.
Okay, I don't want to know your cost price.
Yeah.
So, actually, sell price is 50K. So you're saying I could actually buy a module for 50,000 from you today, plonk it on a piece of land, and I have a livable space.
I mean, there's variations that will occur because the price does vary cost on metals, which I was saying about the economy of materials.
Give or take, it's about $50,000.
But you get married, you need more
So
space.
how many square meters is one module?
15 square meters.
Okay.
All right. So you can comfortably live in 30 square meters, okay, as a single person.
And that's $100,000.
Yeah. Well, plus land, but you get your partner, you grow, you need another room. Boom. You just add another room to the unit. Okay. Yep. Again, fit out can change because it goes between units. It's sort of the similar scenario as boom, you change that wall panel to this wall panel.
Yeah.
And then that becomes a door or an opening or whatever you choose it to be.
So you're telling me you've created a house that's a flat pack Lego IKEA model.
Kit of parts. Yeah.
How does it come? Does it come in a flat pack? Does it come as a box?
We're doing that right now. So we have a trailer development, and the logic is, we have to look at the remote accessibility of the unit. Is that you get a trailer, and the trailer has leaves on it. So all the material stacked in the center, the walls, which are a completed weather-tight unit as you get. They fold down, which would allow you to fold it down onto the foundation of the building, whether it's on a slab or on, a freestanding floor. And those panels will allow it to tilt up so it's easy to manage constructing the structure. So everything's there. It takes about 5 hours to build a structure, as of course with a little bit of experience.
So it takes 5 hours to put that whole thing together.
This thing,
yes. One module.
Yes.
5 hours.
5 hours. 5 hours and
fucking kidding me.
No.
5 hours.
5 hours. 5 hours.
Well,
$500. No.
What is that? What is that?
Boy.
What is that? What is that plonk on? So do you need slab on grade?
Okay, well, that was a later, again, the evolution in this development. We had a commercial developer come in and it was a look at it, and he goes, you'd have a winner here if you developed a base strip, essentially a bottom slab. No, it's another aluminum extrusion that goes on there. And again, we're using aircraft technology. So most of the extrusions that you go, when you look at this, there are multiple places in here for seals.
Yeah.
Okay. Well, you try to look at a triple redundancy that occurs in all these parts. So this base plate that we have can even account for a regular concrete pour, right? So there's 3 different seals that allow it to seal to the concrete slab that's on the ground. And then
but you have to have a concrete slab, though.
You have to have you can have the aluminium freestanding on piles if that's what you want. The aluminium
you can have it on piles. Okay. Yeah.
Okay. So
how many piles are we talking per module?
This
that would depend on the ground conditions, I'm assuming.
We're talking to stop digging, with the screw piles on that. And
yeah.
Each one of the modules completed and clad and everything is about 2,000 kgs.
2,000.
Yeah. Now, here's the weird thing: is everything that we've put together ourselves so far, we've only put it on 4 corners. Okay, so 4 points on it, and
so your point loads are only on the
on
the
that.
4 points. Yeah.
Again, because we don't have a pathway to follow in any of the structural stuff. Like you're looking at 3604 timber. Everything's a timber-based thing. All the science is behind a timber-based thing.
Yeah.
Even our structural engineer has to back
99% of houses here are built with timber.
Yeah. But the structural engineer has to backtrack all the calculations. They have to go, okay, what's really, are we putting 10K in on it? Are we putting 6K in? What's actually the load force that's required per square meter? And so when we test things, we're testing in worst case scenarios. All right. So minimal amount of material. And we've gone, our structural unit that we're testing on right now, again, it's anchored by 4 points. All right. All the units that have been installed so far are on 4 points on the corners. Right. And we've had 500 kgs of people inside there jumping up and down, and we don't have any movement. All right. And that's surprising.
But that would depend on the ground conditions as well, wouldn't it?
Of course it would. I mean, geotechnical on any site is going to depend, especially if it's got any, topography.
So basic principles, what you're telling me is that module sits on either screw piles or a concrete structure.
Yes.
And I could have all my substructure services running underneath.
Yes.
Underneath the modules?
Yes.
So my EPA consents would come bang on straight, connect right through underneath.
Yep.
Either under the slab or underneath your structure.
Pretty much every part has pass-throughs in it for plumbing or electrical.
So what you're telling me is my biggest savings if I go for an adaptable structure that you're building, which is really cool, by the way.
Oh, thank you.
I like it. I really do.
It's trademarked any place.
Yeah.
Yep.
Yeah, nice. I really like it. This is you're kind of solving the housing crisis here. Pretty much.
You think so?
Yeah.
Yeah.
So it's a flat pack system that you can get for $50,000, give or take a module, plus the cost of your slabs, your EPA, absolutely almost zero design at that point. You need a geotech investigation and you need a basic design for a slab or a screw pile, either.
Yeah.
Plonk those on, and I have a house.
Yep.
So there's no design, there's no.
And you can
and I could have a house in a day, from what you're telling me. If I had two,
depends on how many friends you had to come over and help you do it. Because I mean, it's your repeatable actions. You know,
or 2 days, mate. 2 days. Can I have it in 2 days comfortably? I have 2 crews of people, and I want to put 4 modules on. Give them 8 hours each to assemble a module.
Yeah,
I'm a planner. This is what I do.
Obviously, you'd speed up as you go through because you know what you're doing. You know, I mean, we're trying to simplify that right now. We just got our dot peen printer in, which allows us to print on metal, which will have a data matrix code that'll go to instruction and assembly videos, what parts that you need. Yeah. Because the idea is to make this as easy as assembling an IKEA dresser. Easier, actually. So, you know?
Why are you not a millionaire yet? I'm
well, I mean, you're a millionaire.
Why you're not? Okay. Why aren't you a multi-millionaire yet?
Like the guys give me grief over this. Okay. Yeah. I love you guys. Okay. But they give me grief over it. They keep telling me go out the door, but I don't know if it's a perfectionism issue or the risk of fallibility. You know, that you have people identify something that you haven't identified. And I mean, we've tried to get as many people like you've come and visited and you've seen the units to get as much feedback from people in the industry as possible. You know, we've had roofers in, we've had builders in, we've had all this. And then they'll say, well, why don't you do this? Yeah. You know, and we add that in because we have that capability to design that function into the unit.
How many of these modules are launched live today in New Zealand?
What do you mean?
As in, how many of them are out there? People living in these structures.
I can't tell you that.
You couldn't?
No. I don't even know.
You don't even know?
I don't know what you're talking about.
Yeah.
I mean, there's a few out there for testing. Okay?
Yeah, okay, cool.
There's nobody living in them right now.
When are you going live with the product?
Well, the last one that just went out freed up the space in the workshop to do the interior fit out.
Right.
Okay. So the interior fit out was the last thing. But again, you know, if you're going to redevelop construction, there's no sense in not redeveloping interior fit out.
Yep.
Okay. And so we've gone through just the same as an aluminum extrusion goes through this many design variables. We're doing the same. We're in 4th generation of cabinet design, but it's a totally different way. And Luna, you're doing a great job.
Are they your designers?
Oh, mate, they're awesome.
Yeah,
love you guys. So you have to go through these generations, and I mean, because you can't get a person coming out of the university that is already prepped to do this sort of stuff.
They don't teach you this stuff in
They
university.
don't teach you this stuff. Just like you're talking to, you know, the digital 4.0, you know, and turning into digital twins, that's not taught either. You know, designing out waste, that's not really taught. So it's a growth thing with us because we're not cabinet builders. It's a growth thing for her. We're designers, but we look at it and we look at that thing and we go, it's a box. You know, you're making a cabinet, it's a box. Well, what can we do with that box? Well, we already just redesigned boxes. So let's just design smaller boxes that do more things. And so,
and which is completely adaptable, movable all around the house. And
change payloads.
Change payloads, do you say?
Yeah, you can change payloads.
Interesting. That's one of your cabinets, I'm assuming?
That's actually a series of 5 parts.
Yeah, okay.
Okay, but like what you come down to is that you have a system that, like that framing that we were talking about with the smaller boxes, that you put a wall cassette in and those wall cassettes fit in and they pop in, and it takes 24 minutes to essentially change a wall. So if you don't like your door, or you want a different door, or you want a different window, then 24 minutes and 5 tools and 2 people, and you can change an entire wall. And these sort of fit in similar to that sort of scenario. But then again, as I mentioned, the interior, it comes down to why not just have a kit of parts that comes in, you slide that in. Sorry, you having to zoom in on that? Yeah, try to bring it over here. Yeah. Don't worry about you. But anyway, you can slide that in, and it shouldn't be orientation specific as well. So you decide you want to change how you fit out your interior space as well. You should be able to do this with basic tools and just change the interior space.
That is really cool.
And that leaves the opening, the ability to have an opening past the side. So you can have a door out this way, or you could have a door out this way. And those change. Luckily, Gordon, love you too, we've got a guy that's really he's a genius when it comes to bolt patterns. But one of the things that we also discovered early on was with joining modules. So if we join two modules together like this, is why not utilize a 3-meter wall to become the partitioning wall that's in between the units? And then that essentially allows you a meter pass through. So you've now got within the same system.
How did you get past the waterproofing issue? You don't worry about it.
You don't worry about it
because the aluminium.
The waterproof. Well, I mean, you don't have an issue with waterproofing for start.
Yeah.
All right. The building doesn't leak. It's designed not to leak. Okay. But when you join two units together, right, you can take out the internal wall. So 15 square meters becomes 30 square meters.
Yeah.
But in some instances, you want to say, make that your daughter or your kid's bedroom. And then you need a door and they need their privacy. So instead of building a wall, which creates waste, is just buy a secondhand wall off of Trade Me. You can put graphics on it. You can vinyl wrap it. You can do whatever you want. But now you've got that partition between two buildings that allows you the doorway into the bedroom.
That's really cool.
So it's, these are the things that you discover as you go along. Originally, the Keyway, we wasted $120,000. I mean, the material's not really a waste, but with our first production unit that came through, we discovered this application, and then we had to stop production. And that was a 6-month cycle of going through and redesigning all the bolt patterns because you realize that it doesn't have that functionality and you can make that functionality.
What's stopping you from going live? What's holding you back?
I mean,
it looks like you have a winner on your hands right there.
Okay. So this discussion, there is a way to scam the system.
Scam the system?
Yeah.
Tell me more.
So right now, under the current process that's going on here is I have to be a licensed building practitioner. But the only, for me to do what I'm doing right now to build these modules, I have to be.
Are you building or are you assembling?
Well, you're assembling, but you can build. Again, we'll add that. There's a bit of hybrid construction that goes in here as well.
Because all you told me sound like just basic assembly.
It's assembly. Well, they don't have an LBP for assembler, do they?
Yeah.
I mean, you can get those companies that assemble those IKEA for you to come out and do it. But, so for me, like even under the new granny flat legislation that's coming out, okay, you have to be a trusted person to build something, right?
Certified builder.
A certified builder, okay? And that's a licensed building practitioner, certified builder. It depends on, you got to be a member of an organization, right? So, of course, I contacted lbp.gov.nz, and I started the thing, and I need to certify to assemble buildings. And they're like, well, we don't have that. And I'm like, well, I'm not a carpenter. I don't use wood nails, and screws. And he's like, well, we don't certify people or building systems. And so we went down this long line of discussion. This is over about a week or so. And what it comes to find out is my jobs have to be certified by an LBP. So I have to have a chippy that has no clue of what I'm doing come out and risk his license to assemble my buildings. Now that's the cop-out way, the way to scam the system, right, is have an LBP just come out and certify it. But he has no idea about this. Why is he going to why am I going to put him at risk to do something should be completely legal to do?
Because he's certified in doing timber products.
Yes.
And you're doing aluminium, which is
of course
completely different product.
But I have to be an LBP for design and roofing because I've developed a new way to roof a house. Okay. And again, I got triple redundant seals. I'm using a material its lifespan is in excess of 75 years. Again, something that you don't have to service and you don't have to maintain, that can be installed by two people with basic skills. But that's what I have to do. And so I can scam the system, but I'm kind of questioning why we spent, 70 million dollars on the construction sector accord to address innovation in construction. and then at the end of the day, there's no pathway for innovation in construction.
Yeah.
And so okay. Maybe my thing is the reason that I'm not public right now is I'm trying to change the system. I think it's more important that we actually change the world, not me, because this is not a me thing. This is a we project. There's a group of people behind it. Okay?
So technically, you could solve the housing crisis in New Zealand because
everywhere.
Let's break it down to basic maths, right? Okay. So you're saying $50,000 for 15 square meters.
Yes.
So how much is that per square meter of house?
3,000 something.
3,000. Yeah. So traditional builds now cost anywhere between, I think it's about $5,000 to $7,000. Yeah, to build. It's a traditional house.
I don't
give or take. I know.
That's the math. We're going to talk economics here.
I know. I'm just going to basics, right?
Yeah.
You've just literally halved the cost of building a house, which is completely adaptable. You see where I'm going with this? And you've reduced design cost. You've reduced literally your transport, your build time is reduced. There's so many efficiencies in that process. You should be going live.
Oh yeah, I should.
I know.
I should.
I know. There are things holding you back, and there are compliance regulations.
Okay, but you go down a bigger issue, and this was the discussion this morning. Was you go down a bigger issue of insurance and bank acceptance, and all of those. There's three things in it: government, banks, and insurance. Okay, and those three are all in bed together. All right, so they essentially control what's going on. It's just like you at the end of the day going out and to buy a section. 20-something goes out and buys a section. You have to have a 50% deposit. Now, you can't get anything instantaneously on that section. There's no way to get it. You still got to go through 6-8 months of consent process and all of that. So now you're stuck with a mortgage, paying rent, and paying all those consultants to do that.
Yeah.
And my question that I was trying to pose to the banking world was, what if I could have a house on there in a week?
Yeah. Because you need a couple of days to get your EPA services in, connect back to services, pour a slab, plonk those modules on. Where
That's
you
right.
go,
even if you use a composting toilet.
Oh, hang on, you need CCC though. You need all council's approval.
So, but what if I get multi-proof approval?
Yeah.
Okay. But even multi-proof doesn't address this kind of construction. Okay. And the reason that multi-proof doesn't address this kind of instruction, and it kind of kills off the circular economy aspect, is you have to have that LBP build it for you. If you make any alteration to this house, it has to be an LBP or certified builder that comes out and does the work.
Why?
I'm not the government. I've had MBIE policy writer, one of them come in.
But hang on, all your structural point loads are on 4 points.
As long as they build it.
So you're not changing those your point loads. You're changing everything else in your structure.
Yeah,
that's interesting. So why would you need another certification for interchangeability?
I mean,
that's a really good question.
I know it's like that. It's a tough one.
Who do you put that question out to? Put it out to who in this industry can answer that question?
Well, so far I've found nobody. Okay. And I've gone top to bottom. I've had CEOs of government organizations back and forth and this, that, and the other. And there is, matter of fact, 2 nights this week, I've been on legislation tracking down what the companies or what government organizations under legislation are supposed to be dealing with innovation. And you would be surprised how many are. Now,
mate, it sounds to me like you're chasing your tail a little bit.
No, I think I can change it.
You reckon?
Yeah, no.
I hope you do because I believe in that product. It's really cool. And I've been at your factory. I've seen a life-size model of it. It's a really cool product.
I mean, the thing to me is the people in need globally, right? And that we've developed a technology that as long as there is a foundry that can extrude aluminium in any country in any place in the world, we're essentially looking at maybe $200,000 investment, and you could be producing houses
as long as you can extrude aluminium, right?
They asked me this morning. What problem does this solve? And to me, it solves equity, because now you've got houses that are standard, that are safe to live in, that can exchange within a community. for instance, if this was an iwi housing thing and you had an empty nester that had a spare room they didn't need in a family that just had a new baby, well, they could donate that room to that family. And that could be done as a community thing.
That's really cool.
My biggest...
So I could be selling part of my house to somebody else.
Yes. And see, and my biggest question for government, and I'll look at you right now and I'll stare you straight in the eye, is why are you trying to stop change? Where is this material entrenchment? And we talked about the economics of it, and aluminium is a traded metal. So it goes on the London Metals Exchange. As we know, aircraft production is switching from aluminium to carbon fiber and composites. So the use of aluminium is starting to decrease in one of its major sources, and there is a push to use it in construction. Right now, the price of aluminium is high. I told you $50,000. The price of aluminium is high. And the reason the price of aluminium is high is because of the war in Ukraine and the energy crisis that's going on in Ukraine. All the smelters in Europe have essentially closed down. I think they just opened another one. So we fluctuate on prices, all right? It goes up and down. It's a traded metal, right? Timber's not really. Timber's one of these things sold by board foot. They try to speculate on pricing and all of this with timber. But the one thing that we've seen is that timber prices have continued to increase.
They have. You're not wrong there.
You don't see it decreasing. Okay?
Can I ask you a different question on timber though?
Sure.
This is an interesting question.
Yep.
How many trees would I have to cut down to build a traditional house?
Well, that's a variable question depending on how you ask. I don't know if you read that article I sent you.
Yeah.
It's between, they say between 60 and 120, and that was for a 2,000 square foot home. I don't know what that correlates back into square meterage.
Mate, you're testing my math skills.
Yeah, so...
What? Come on, you're in New Zealand. You need to be talking square meters, not square feet.
Yeah. Well,
Goddamn Americans, I tell you.
You go on where the information comes from.
Yeah.
Okay. It doesn't mean it's necessarily right. Now, I think that.
So how many trees did you say?
Between 60 and 120. Again, it depends on the standard of home and everything else.
So that's the number of trees now not converting.
That's carbon dioxide to oxygen.
Exactly.
And our logic is we should be celebrating not cutting down trees.
Yeah.
All right. Because even though they say that we have this thing that the carbon cycle in trees and forestry is all, it's just that little circular economy that they work out, and they celebrate that they've got so much carbon storage. Why does CO2 keep going up? So we need more trees because trees are one of the two natural ecosystems that control carbon dioxide in the atmosphere. We haven't been very good stewards of the land in that instance.
Yeah.
But now we want to mine the oceans as well, which is going to screw up that ecosystem. So there's not a lot of logic going on this natural resource, and the way we look at it, natural resource or human resource, and forest should be looked at as a human resource because it's in charge of the atmosphere.
Yeah, right. Interesting.
It's used as a natural resource because we're farming it, and we all see, and like, because of my environmental background, let's go on this one little point real quick, is right now, like looking at the ETS system and what was done under the ETS system, there's a lot of emphasis on farming. Okay. And I hope the Federated Farmers are watching this at this moment. But there's a lot of emphasis on farming. They measure cow farts, and I in my environmental career here, I talked to people that waited for cows to pee and catch it with a bucket. Okay. And that was part of their science program. So we've diagnosed every single aspect of what occurs on a farm. Okay. Nutrient loading, carbon dioxide, methane, all of this. Okay. Now, anything that crosses the fence line is considered an emissions. All right. So you release it, you pay for it. Now they got to offset it with ETS or whatever. You're going to grow a forest and you're going to offset it. Now, when we look at timber is an industry as well. It's
a huge industry.
It's a huge, third biggest in New Zealand.
Yeah.
Okay. But what we do is we're math smithing data.
Are we?
Yeah, we're math smithing data. Well, because
is this going to come back to how we
it's going to piss some people off right now.
Probably
man.
will.
Let's get them. Let's piss them off.
So is this how we measure the emissions? Or how we measure ourselves as sustainability?
It's not a level playing field, is it?
All right.
Because you look at forestry, you go in and you do a cut.
Yep.
Okay, and you take it all out, and they leave all the slash on site.
Yeah.
Okay, we had it like the cyclone. The cyclone came through and washed all that slash downstream, blocked up bridges, flooded entire towns. You know, I mean, you've seen the pictures. You know, there's slash up to window sills.
Yeah,
that's not counted.
Yeah, right.
So that slash has left the fence line. Now, why isn't that calculated in the entire carbon footprint of that process? That's because timber processing is credited.
Interesting.
So we essentially have the best carbon trees. New Zealand calculates carbon. It's the only place on the planet that does it this way. Okay. If you look at the carbon leadership.
So what you're telling me is we're just kidding ourselves.
We're kidding ourselves. I mean, we like, I read an article the other day. This was posted on one of the sustainability things. It was talking about offsite construction reduces 40% of the carbon footprint of houses, right? Or manufacturing houses or whatever it was. Maybe it was like 40 to 60%, some grand scheme. Now, how is that possible if you're building to the same code? You're transporting the same mass, right? It actually should be worse because you need a giant factory to build this. Okay, what's the carbon footprint of that factory? You need 2 teams of people to manufacture it, one in the factory and one out on site. Now, sure, it may speed up construction, but how can it actually reduce carbon? Same method, right?
Yeah.
And that's what I mean about industrializing a method. You're actually making more impact because you need giant factories to do this.
Yeah.
You know, if you industrialize a method of construction, you're industrializing all the waste into that aspect.
So you're not constructing anymore.
Well, I mean, I had this discussion with Autodesk one day.
Autodesk, did you say?
Yeah, Autodesk, you know, giant Autodesk, digital twin.
Yeah.
You know, construction.
So all the things I care about, mate.
Yeah, you love that.
I love that shit.
Okay. Oh, here's one for you.
Yeah.
All building material comes in a standard size.
Yes.
All right. How come there's not a tool in Autodesk that tells you to optimize your thing because you're generating a certain amount of waste?
Interesting.
Right? How come there's not a standardized house? I mean, maybe Signature Homes is the one that's got the best recipe.
Yeah.
You know, they standardize as much as they can to reduce the amount of waste that they can. Sure, you can design some of it out, but in general, think of a 6 meter stick of wood, right? A timber. You're going to cut that down and you're going to make studs. How much waste is in that?
A lot.
You see? You might get a noggin out of it, you know? But there's by default waste in the process.
We design for waste. We design to create waste.
Yes.
We design to create
everything that we're building right now is inevitably going to end up in a landfill.
You just opened up a can of worms here, haven't you?
Oh, yeah. Well, you only gave me an hour.
Well, I don't get more than an hour. No, we're going to get kicked out of here.
Cut you off. Well,
We're going to get kicked out of here.
I mean, essentially everything. I mean, think about a giant corporate building that's being built downtown right now.
Yeah.
Is that designed to retrofit to apartments?
Nah.
Yeah. Did they put
it's designed for one specific purpose and one specific purpose only.
It. So how are we not designing for waste?
Yeah, interesting.
You know, and I mean, I think that we can do better. And one of the questions that I'm sorry, one of the questions I came up with you was the $100 million. What do we want for $100 million? Right?
Yeah.
Okay, we seem to.
So is this where I gave you $100 million?
Well, you want to give me $100 million. I'm trying to think that what's the objective of the $100 million to start off with? What's the objective to do with this? Now, if you gave me $100 million, I'd disappear. I'd be gone. All right, I don't care. Right, but if there's a point to the $100 million,
would we find you in Las Vegas?
Yeah. Well, I mean, let's talk about the urban light rail or whatever it happens to be at the airport. $100 million. Okay, they want $100 million. They spent $100 million. What did they build? Elon Musk took 110 and built a reusable rocket. So what do we actually want out of $100 million? I know it's just a big number to throw away.
Yeah.
You know, or throw around.
In the grand scale of things, it's not a huge number.
It is a huge number. That's retirement money there, buddy.
It is, but then compare it to City Rail Link that cost us $5.5 billion for 3.6 kilometers rail track.
Okay.
You're talking about $100 million.
Okay, $100 million.
Is not massive in the grand scheme of things.
Here's another one to throw at you.
Yeah?
Are you aware that, so we just spent $100 million talking about digging up Dominion Road and putting rails on it. Okay. This is government logic. $100 million bucks.
220 to be specific.
Okay. You want to be truth about it. Are you aware that we own a bus lane that runs parallel to Dominion Road, that we've already owned all the property for years because they already did that we're going to put a bus lane along Dominion Road.
You're right.
Like 10 years ago.
Did they?
So Auckland Council already owns all that. They own the countdown. They own the land that the countdown's on.
On Dominion Road, they actually own that land?
They own the old warehouse on Balmoral.
Oh, wow.
Didn't know that, eh?
I didn't know that.
How is this possible? How is that we did a study, we bought all this property, then we never did anything with it, and then we go and talk about digging up Dominion Road, which is a major thoroughfare for traffic in Auckland, and just disrupt everybody when you already own adjacent land to it. So what the hell are we doing? That's what I want to understand. We spent $100 million. Jesus Christ. If you gave me $100 million, I reckon if you gave me $100 million bucks and you gave it to me right now, I reckon I could get you world peace and anti-gravity.
Mate,
I don't even know what I could do with probably more.
Are you sure you're not smoking pot?
Well, I could. Would you like to?
Oh, man.
It just becomes. You think it's a ridiculous number.
Yeah.
But a ridiculous number is $400 million for Wellington Town Hall. When in Dubai, $400 million makes a city.
Yeah.
That's ridiculous. So I don't know that we're.
I get the point. Cost of construction in New Zealand is ridiculous, right?
No, the talk of construction is ridiculous.
Right.
Here we're now talking about building another stadium downtown, and what stadium has been good business in this country? Maybe works down south, but not up here in Auckland. Eden Park, for instance, still owes $30 million to Auckland Council. Maybe it's $23 million. But that's from World Cup.
Oh yeah,
2011. So.
Yeah, interesting. You're full of stats, aren't you?
I'll read the newspaper.
Oh, I'd recommend stop doing that and listening to more podcasts.
No shit. Well, the guys do love your podcast at work.
Yeah, that's awesome.
Yeah,
that's awesome.
Yeah.
All right. I think we're
done.
We're rolling a lot, but before we wrap up, I do have one other question I want to bring up.
Okay.
You told me you're doing all of this because of your mother, and you brought her here today with you.
Yeah, my mom, dear old mom, she's an architect developer.
Yep. Go on. Tell us a bit more.
Well, my mom was in Passive House in 1974. She was big on everything architecture. So I grew up in an entire library of architecture stuff, and every day when I came home from school, she was on the drawing board doing. This is all pre-CAD.
Yeah.
This is all pre-women in construction and all this, and so she was in a male-dominated field, and I don't know. I just felt the passion that she had for it, as well as I guess somewhat the outrage of why it's done the way it is and why it's got to be a male-dominated field. It's just like we were just talking. This seems to be a consultant-dominated and government-dominated field. Doesn't seem to be a logical sort of thing that's going on here. So this is why I kind of get my fight out of this, is to see the things that she tried to do that fell through, and then here I'm trying to do the same thing, and I'm not going to quit.
Good on her.
So I'm not that kind of person that's just going to give up on this.
Yeah.
I'm going to be the thing that's scratching you in the back constantly. That
the
you
vigilante
just can't
builder,
reach.
Eh?
The vigilante. You're just not going to reach that itch.
Yeah. Yeah. Good on you, mate.
So
good on you.
I'm going to keep trying. That's all I can do.
Mate, I'll tell you what. Thank you so much for your time.
Well, thank you. I appreciate being invited.
Yeah,
it's an honor.
I really hope Adaptable Structures takes off, like flat pack Lego housing.
Well, we just need
IKEA
the government.
Housing.
We just need the government to engage. That's all.
That shouldn't be hard. We should give Minister Chris Penk a call. What do you reckon?
Hey, Minister's been out there. He's seen
Has
it.
he?
Yeah, I'm not throwing him into this conversation. Hey, he's a good guy. He's a nice guy. You understand?
Yeah, no, he's a good guy. He's been on my podcast as well.
Yeah. It's good to count anybody as a believer. And that's what all we're trying to do is get believers at the moment, and then hopefully through that we can change.
Right, you could solve housing crisis in New Zealand, and I believe that.
I mean, I
strongly believe that.
Yeah,
and
I mean, I hope people can see that.
Yeah,
so that's our intent. We're not. This is not about becoming a billionaire. This is about solving a problem.
Yeah,
you know.
And I wish you all the best, mate. And I hope you succeed. Right.
Yeah.
And if you ever want to come back on a podcast, I know
I'll do it anytime. Let's go.
I know, Guy.
I mean, you get that 6-pack of beer and we're in.
Done. No.
Yeah. You need a sponsor?
No, I do need a sponsor. I do need sponsors.
You need beer sponsors, and then we're
sweet. Beer sponsors, whiskey sponsors.
This is sponsored by water.
And on that note, thank you everybody for watching.
Somebody can do better.